AP Calculus AB. We're going to call this day 614 assignment. Okay. What it is it's the 3 related rates problems from the back of day 612. So that's going to be 3 of them. And then the 4th problem is on the back of the day 1 notes. And it was Lighthouse Rock. So that's the other one. So these 4 problems we're going to count as day 614 assignment, counted separately from the 612 assignment and so forth. So these are good. These are good. This is good like pre-test for your test for the related rates part. So you're gonna have 3 of them. And I would say most of these kind of hopefully are starting to feel familiar or similar to something we've done before. So Morgan leaves AG due south at 60 miles per hour when it actually leaves Baco 150 miles due east of AG for AGHS with the same speed as Morgan. So however you want to do it, we could say, okay, well, here's AG. Morgan leaves AG due south. So this is Morgan due south. And Ashley leaves Bakersfield, which is 150 miles due east. So this is Ashley, and she's going that direction, and Morgan is going that direction. So I like to draw little arrows to show the directions. 60 miles an hour is this rate, and this is 60 miles per hour. And let's see. Same speed, 1 hour after Ashley left Bakersfield. 1 hour later, Ashley. Okay, so Morgan left earlier, and then we're saying 1 hour after Ashley left Bakersfield. So it's been 1 hour. So it was 150 to begin with to Baco, but she's going to be closer than that after she's been traveling a while. So she's been going for 1 hour, 1 hour after Ashley left. That means that Morgan's been going 2 hours. I think that's good stuff to add to your picture. And it says, how fast is the distance between she and Morgan changing? So that'd be the length of this. So we need to probably create some variables. I'm going to call this A, B, and C. You can use X, Y, Z. You can use whatever. Make sure you label it on the picture if it's not already in the picture, because people are going to choose different things. The relationship between these is going to be A squared plus B squared equals C squared. Are any of these constants A, B, and C? No. So it's going to be 2A dA dt, take the derivative implicitly, plus 2B dB dt equals 2C dC dt. Now dC dt is the thing we want, right? Now this 60 miles an hour, if we put A here, then this is going to be our dA dt. Is it positive or negative? Is A getting bigger or smaller? Bigger. It's positive. This 60 miles per hour, this is going to be dB dt. Is it going to be positive or negative? Negative, not because it's moving to the left, but because B is getting smaller. Do we expect dC dt to be positive or negative? Well, this is coming in and this is going out. So this one's getting closer and this one's getting further. So it's kind of hard for me to tell because they're going the same speed. I'm not sure. Sometimes it's really obvious. I feel like it's not as obvious here. We do need to probably get some lengths for these things to plug in A, B, and C. So we're not going to plug hours in, but distance equals rate times time, right? So this distance, 60 miles an hour times 2 hours is going to be 120 miles. That's going to be A. And here, B is going to equal rate times time. So 60 minus, it's going to be positive 60. We're not going to say negative 60. The negative is just because B is getting smaller. And then C, we probably got to figure out what C is because we're going to have to plug C in. So we can do Pythagorean Theorem, 120 squared plus oh, shoot, I made a mistake. So she's traveled 60 miles an hour, but she was 150 to start with. So now she's 90 away from AG. We have to subtract the distance she's traveled from the original distance. So That was a tricky one right there. So we're going to get 144, 2 zeros, plus 81, 2 zeros. And then we can add these together. 0, 0, 5, 12, 225. We can take square root of both sides. And so C equals 150 miles. So I think we have everything we need. So A is 120. dAdt is positive 60. Plus B is 90. dBdt is negative 60. Equals 2 times C is 150. And dCdt is what we're trying to find. So now we just gotta clean this up. That's gonna be 12 times 12, 144 with 2 zeros, minus 6 times 9 is 54, 108 with 2 zeros, equals 300, dCdt. And we're gonna divide by 300. So dCdt equals 12. And what are the units? Change in C would be length, so that's miles over time is hours. So you could say that, 12 miles an hour, 12 mph. And it's positive. It came out positive. So there you go. It's a good one. Number 17 has a cone. Probably expect a cone on your test, maybe, right? I don't know. It seems likely, possible. We've done a lot of cone problems. Coffee pours into Matt's coffee maker at a rate of, so it's pouring in. This is like a filter at 6 cubic inches per minute. Find the rate of change of the coffee height. So there's a coffee height in here. And so that's H. So we're getting a right triangle here. This is the radius. And then you have the original right triangle. So we're getting similar triangles, of course. Cones, we always use similar triangles. It says find the rate of change of the coffee height when it's half full by volume. So we're looking for dH dt when the volume equals half full. Okay, so well, we need an equation for the thing we're trying to, find the rate of the volume related to the other one. So volume of a cone is 1/3 pi r squared h. We really like to get in terms of all one variable. So should we go for all r or all h? Well, we're looking for dHdt, so we probably want all h, right? So we got to use similar triangles. We can say r over h equals 4/6. So then r equals 2/3 h. We're going to plug that in for r so that we have all h's. So the volume equals 1/3 pi parentheses 2/3 h squared. Make sure you put parentheses around it because the 2/3 has to be squared too. So this is going to be 4 pi over 27h cubed. This is the volume formula we want to use. And it's easier to do that up front. You're going to have to do it eventually no matter what, but it's just easier to do now because the derivative is going to be much easier. No product rule. It's going to be 4 pi over 9 h squared dH dt. dV dt is probably a better way to write this. dV dt. Is the rate positive or negative? It says pours out of coffee maker. So really, oops, I wrote it up here. It's down here. This is dV dt, by the way. And for us, it's negative because we're losing coffee, right? So the one thing we need, we have dV dt, we need h. So, we have dV dt. We need h. And then we're almost done. So this is going to be the next hard part. We got to find the full volume. Now the full volume, you could use the original 1/3 pi r squared h because you have all those, or you could use your new formula. The h is 6 when it's full. cubed. So it's 6 times 6 times 6. And so we could divide a 3 out of this, and 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 a 3 out of this. So it's going to be 32 pi when it's full. However you want to pull that off. So the full volume is 32 pi. And so half full is going to be 16 pi. And then we want to figure out what the height is that goes with that. So it's going to be, we're going to use the 4 pi over 27 h cubed. And then we're going to solve for h. So we could divide a pi out of both sides. So h cubed equals 16 times 27 over 4. So reduce that. Then we're going to take the cube root of both sides. And I'm going to do it before I multiply this out, because then the cube root of 27 is 3. And then there's a cube root of 4 left over. So that's our height, is h equals 3 cube root 4. And we're going to plug that in up here. So it's going to be 3 cube root 4, and then it gets squared. So now we're just going to try and clean this up. Negative 6 equals, now the 3 squared gives you a 9, and that cancels that 9, so that's gone. And then we get cube root of 16, which we could simplify. We could say, well, we take 8 out of there, right? So negative 6 equals 4 pi times 2 cube root of 2. And then we're going to divide both sides by that. So 4 pi times 2 cube root of 2. 4 pi times 2 cube root of 2 cancels out. Reduce the 2 with that, it gives you 3. So we could say dh dt equals negative. By the way, we expect it to be negative. The height should be decreasing. So that's going to be negative 3 over 4 pi cube root of 2. And the units for height should be inches, and the units for time should be minutes. So that's good. Or if you want, you could rationalize the denominator. You multiply the top and bottom by the cube root of 4 to get a perfect cube. And the answer would be negative 3 cube root of 4 over 8 pi inches per minute. So that's the same thing, but with a rationalized denominator. On a calculator, negative 0.189. 3 decimal accuracy, rounded truncated. So, I don't know, seems like a good problem. The cylinder is inscribed in a cube as shown. The perimeter of the top of the square is increasing at 12 feet per second. As the cube expands, so does the cylinder to maintain tangency. When the surface area of the cube, that's all of it, is 96 square feet, what is the rate of change of the shaded volume in between the cylinder and the cube wall? So this is a cube, so all the sides are equal. Side, 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 side. And you have a cylinder that has a radius. What's probably going to be helpful is to probably think of the sides as 2r, right? The diameter would be 2 radius. Because we're going to want all one variable. And I mean, if you can start taking care of that ahead of time, we didn't have to do anything fancy like similar triangles in the last problem. Now, the perimeter of the top square, so that would be dp dt equals 12 feet per second. So we probably need a perimeter equation, which would be 4 sides, or 8r. And so we're probably going to use that at some point. What is the rate of change of the volume? So what is the volume? The volume is the volume of the cube minus the volume of the cylinder. The volume of the cube is side cubed. The volume of the cylinder is pi r squared h, general formulas. Now we can get it a little more specific. Like I said, we probably want to go ahead and get all one variable. And you could make all the r's s's, but they'd be s over 2 and you get a bunch of fractions. We can make the s's 2r, which I think is a little nicer. So you can plug 2r in. By the way, the height of the cube is r because it's a cube. So the height's the same as all the sides. And so we get the volume equals 8r cubed minus pi r cubed. So this is our volume formula that we probably want to use. And we want to find the rate change of the volume, so we can do dv dt equals 24r squared dr dt minus 3 pi r squared dr dt. Okay, so we need the radius and we need dr dt. So I think we're going to get dr dt from this. So if we take the derivative, dp dt equals 8 dr dt, and we know dp dt is 12, right? So then dr dt equals 12 over 8, 3 halves. So that's dr dt. And it says it expands. So everything's positive. Everything's getting bigger. So that's our dr dt is positive 3 halves. But we still need the radius. And they gave us another piece of information. It said when the surface area of the cube, what's the surface area of the cube? It has 6 faces. So it's 6 times the area of it's 6 squares. They're each side squared. They're each, if we turn it into r, they're each 24r squared would give you the surface area. And so we need r, and they told us the surface area is 96. So from that, we should be able to get r. So we divide by 24, take the square root of both sides, plus or minus. Of course, we want the positive r. So that's what we're going to plug in here, squared, here, squared. So we're almost done. So we could cancel one of the 2's with this 2. We get 48 times 3, 120, 144. We could cancel one of the 2's with that 2. So we get 18 minus 18 pi. Did I make a mistake? I think I made a mistake somewhere. 3 pi r squared. Oh, the volume of the cylinder is pi r squared times the height. Oh, the height is 2r. The height of the cube is 2r because all the sides are 2r. So there should be a 2r there, which means that we have a 2 pi r there, which means we're going to get a 6 pi r squared here. This should be a 6. And this is going to be 36. Ugh, little tiny mistake. Units, feet cubed over seconds. If you want to know what is this decimal, it'd be 30.903. 3 decimal accuracy. So those are all real good problems. I think they all are very close to problems we've done before, maybe not exactly. And then the other one is from the back of the day 1 notes. I think I did not go over it yet. So this is now going to be part of 614. So this one, it had a warm up. This is day 1 notes. We did balloon problem, oil spill, the shadow problem, and then in the back, this one's probably blank still. This is a very classic problem. And it probably feels a lot like the first one we did. Ship A is traveling due west. Well, which way is west? It's to the left. Ship A is traveling due west toward Lighthouse Rock. So there's all kinds of clues. At a speed of 15 kilometers per hour. Ship B is traveling due north away from Lighthouse Rock at 10 kilometers per hour. Let x be the distance between ship A and the Lighthouse Rock, and let y be the distance between ship B and Lighthouse Rock at time t. Find the distance in kilometers between ship A and ship B when x equals 4 and y equals 3. I'm going to call it as z. So we got to figure out what z is, and that's just a little geometry at the beginning of the problem. But that might also set up some of the relationships that we're going to need to use later anyways. So it's going to be x squared plus y squared equals z squared. So it's going to be 4 squared plus 3 squared equals z squared. So it's going to be 16 plus 9. And so that's going to be 25. And then we take the square root of both sides, plus or minus. Of course, we want the positive. And the units are kilometers. So that's part A. Just some quick algebra. B, find the rate of change in kilometers per hour of the distance between the two ships when x equals 4 and y equals 3. So we're trying to find dz dt. If you use z for the hypotenuse, we're trying to find dz dt when x equals 4 and y equals 3. Now, can we guess if it's going to be positive or negative? This one's coming in, making them closer. This one's going out, making them further. But the one coming in is coming in faster than one going out. So I kind of think they're getting closer to each other, and we should expect a negative answer because the distance is decreasing between them. I'm predicting a negative answer. Now, we need a relationship. Okay, we should probably add some more stuff to our picture. So this is, if y is here, this is dy dt. Is it positive or negative? Is y getting bigger or longer or shorter? Longer, so that should be positive. I put that plus there. And every time I plug it in my work, I'm putting that plus. This is dx dt, and I'm going to put a negative on it because x is getting smaller. So I think that's good. We need that stuff. So we need a relationship between all these, dx dt, dy dt, and dz dt, and we actually already used it in part A, Pythagorean Theorem. X squared plus y squared equals z squared. Are any of these things constant? If they are, let's plug them in now before we do the derivative. It'll make our life easier. None of these are constant. Do not plug in x equals 4 or y equals 3 yet. Don't, because they're changing. So we take the derivative, 2x to the first, dx dt, plus 2y to the first, dy dt, equals 2z to the first, dz dt. This is the thing that we want. And we have everything else. We have x is 4. We have dx dt is negative 15. We have y is 3. We have dy dt is positive 10. We have z is 5. And we're looking for dz dt. So now we just got to clean this up. 60 negative 120 plus 60 equals 10 dz dt. 10 dz dt equals negative 60 divided by 10 dz dt equals negative 6. What are the units? Z is a length. It should be kilometers, time is hours. So it's negative. Says find the rate of change of the distance between the ships. Negative 6 kilometers per hour. Part C says let theta be the angle as shown in the figure. Okay. Find the rate of change of theta in radians per hour when x equals 4 and y equals 3. So on part C, we're looking for d theta dt. Do you expect to be positive or negative? Think about it. As this ship comes in and that ship goes out, the angle is getting bigger. We should get a positive answer. If you don't, something's wrong. By the way, we got a negative answer on the last one. If you'd forgot to put the negative 15 here, you wouldn't have got the negative answer. And then you would be like, oh, obviously something's wrong. Now we need a relationship between theta, x, y, and or z. There's a lot of ways we could do it. You could do sine of theta equals opposite over hypotenuse. You could do cosine of theta equals adjacent over hypotenuse. You could do tangent of theta equals opposite over adjacent. I personally am going to pick this one because I would like to avoid using z as much as possible, because what if we hadn't found z yet because we didn't do parts A and B? What if we got it wrong? What if we got it right and it was this ugly number that just made our work hard? I like to work with the original information because I know it's right. I know I don't have to do extra work to find it. I know it's probably prettier than other information I can get. So I'm going with this one. I mean, some of the drawbacks is the derivative tangent's a little more weird than sine and cosine. So we're going to take our derivative of this. Derivative tangent is secant squared theta. Don't forget the d theta dt, which by the way should stand out to you because that's the thing you want, right? Now this guy, you could do a quotient rule, or you could do a product rule with a negative exponent. It's up to you. I think I'm just going to go for the quotient rule. I don't think it's that much messier than what that would be. Sometimes when you rewrite it with a negative exponent, it's way easier. You still got a product rule. Low d high minus high d low all over low squared. Now, we're looking for this. We have x, we have y, we have dy dt, we have dx dt. We don't have secant theta. I'm going to do that in a second. Okay, we'll figure out what that is in a second. I'm going to just fill in the rest of this stuff. X is 4. dy dt is positive 10. Y is 3. And dx dt is negative 15. If you forgot this negative, I think you would end up getting a negative answer, and we know we should be getting a positive answer. X is 4 squared. So we got all that. We just got to figure out what this is. Now, secant is 1 over cosine, right? Squared. And cosine is adjacent over hypotenuse. Okay. So what is the adjacent side to theta? It's 4. What's the hypotenuse? 5. And then it's got to get squared. So this is the same thing as 1 over 16/25, but we're dividing by fraction, so it's actually going to be this is the same thing as 25/16 d theta dt equals 40 plus 45 over 16. So to get rid of this, I'm going to multiply both sides by 16 over 25. Those guys cancel. We get 90 or 85 over 25. We could reduce it. Take a 5 out 17 times over 5. The units for angles should be radians. They told you to use radians, but by default it's radians. Over time was hours. So there it is. It came out positive like we thought it should. Should be getting bigger. And there you go. So that's a good classic problem. It has a lot of good stuff in it. But you need to be ready for related rates on the final. You're going to have 3 problems similar to these and other ones that we've seen. You've had a lot to practice, but this is kind of like your pre-test, for the final. These 4 problems: the back of worksheet 12 and the back of notes day 1. We're going to call that assignment 614. All right, make sure you always put your units, think about the signs, label your graphs, draw your pictures. When you create variables, again, make sure you put them on the drawings so I know what it represents.